Okay, so today's a good day to pay attention because we're going to review inclined planes, and then I'm going to go over what you can expect on the quiz that you have tomorrow, which is a great opportunity for you to demonstrate what you know. So the first thing I'd like to do is to start off with the example problem we ended with yesterday, where I said, here's an example, try it out on your own, and then tomorrow I'm going to go over the answers. Today is that day. Great question. That's on the next slide. I'll let the suspense build. All right. For the example that you had yesterday, 12 kilograms on an incline of 40 degrees. The first thing you want to do is to draw and label the free body diagram. That is to illustrate the forces. So we have the weight acting straight down, the normal force perpendicular from the surface. It's not straight up, it's perpendicular from the surface. And then the force of friction, which opposes motion. So for a block that's sliding down the incline, friction is up the incline. And that's all you need for part A. For part B, the force that acts down the incline. If you recall from yesterday, when you have objects on inclines, you can resolve the weight into two things. First, the force that acts down the incline is known as the parallel force. When you take the weight, sine theta, and also the force that's perpendicular, which is equal to the normal force, is the weight cosine theta. This is true when you have inclines. That is true when you have inclines. So for the force that acts down the incline, we've got 12 times 9.8 sine the angle. The angle is 40 degrees. So that component of the weight that acts down the incline, which is the parallel force, it's about 75.6, about 76 newtons. For part C, what's the acceleration? If we ignore friction, if there's no friction or if we ignore friction, then the net force is just the force down the incline. Nothing stopping it. So acceleration is that net force divided by mass. So the acceleration would be 6.3 meters per second squared with no friction. It's not very realistic though, because typically you have friction. How is friction going to impact the acceleration? It's going to make it more or less? It's going to be less. So for part D, to find the acceleration, we're again going to say net forces over mass. The net force is 76 newtons, the force down the incline. And what are we going to do with the friction? We're going to subtract the friction from the force that acts down. So parallel force is the force, the component of the weight that acts down the incline. Friction opposes it. Force of friction is the fun equation, the coefficient times the normal force. That's the coefficient. The normal force is the weight cosine theta, right here. And when you find the net force, you divide the whole thing by the mass. Giving you an acceleration of about 2.55 or 2.6 meters per second squared. Okay, this is also typical of a free response problem that you would have tomorrow. So on tomorrow's quiz, which will be two parts like the other quizzes that you're used to, is half multiple choice, half free response. Again, similar to what you're used to, I think. Consists of 10 multiple choice to start off with, followed by the 3 free response. here are some things that you should know. If there's no mention of friction, then you don't need to worry about it. You can ignore it. It's negligible. It means you can ignore it. On your formula sheet that you'll have available, you have your linear equations, in case you need to find the acceleration. F equals ma, or acceleration's net force over mass, same thing. Weight's mass times gravity, that comes from F equals ma. Force of friction is your fun equation. You should know the difference between mass and weight. What's mass measured in? Kilograms. Weight is a force. All forces are measured in what? Newtons. For the free response, you have three. One's going to be a vertical pulley. One's going to be a block on the table, kind of like the lab where we did examples where we had an object on the table connected to a pulley, something hanging vertically. And then finally, one with an object on an inclined plane. So we're going to do examples of these again. We've already done examples, but we're going to do more examples to see how you do. Okay? So for the first one, $60 kilograms as the mass. You're pulling with a force of 150 newtons at an angle of 37 degrees. This box of books is accelerating to the right. So in order for us to find the acceleration, you have to find the net force divided by the mass. To find the net force, you think about the direction of the acceleration. If it's accelerating to the right, what force are we going to find? How are we going to find the force to the right? Do you remember how to find force in the x direction? What do we use? Find the adjacent side. Yep, more specifically, cosine. So tomorrow, when you have a force of 150 newtons at 37 degrees, you can take that force, cosine of 37, to find out the force just acting horizontally, since that's the direction of the acceleration. Divide by the mass, get an acceleration of about 2 meters per second squared. Other multiple choice. If you go to the moon, what can be said about your mass and weight? If you go to the moon, how does your mass change? Doesn't. It stays the same. How does your weight change? It decreases, right? If there's less gravity, there's less weight. Your mass, however, doesn't change. Next one, sports car. To find F equals ma, you have to know the mass and acceleration. For this one, we don't yet know the acceleration, so we have to do this in 2 steps. We first have to find the acceleration, and then we can do F equals ma. We start from rest. We get up to a speed of 27 meters per second in a time of 7 seconds. So one way you can do this is V equals VO plus AT. We can find the acceleration. Now that you know the acceleration, you can use F equals ma. Okay, so that's an example where you found the acceleration, then you applied F equals ma.
Using significant figures, wouldn't it be 3.9?
You could see this as 3,900 newtons. You could see this as 3.9 times 10 to the third newtons. You could even see this as 3.9 kilonewtons, because you're right, in multiple choice form, correct number of significant digits, you might have one of these choices and then a bunch of other choices. But yeah, you wouldn't have this choice and this choice. You'd have one or the other. In this case, if you had two significant digits, the answer would be in 2. Or 1,000 could actually be one significant digit, but you're not going to have any choices with just one. Crazy. Okay, the hockey game one. This one is probably the most challenging of the multiple choice. So take just a couple minutes and see how you would set this one up. Okay? So try this one.
How many questions will we have to use like linear equation?
2.
Yep.